Cosine rule is another rule which lets us work out missing sides and angles of triangles that are not right-angled. We use the cosine rule whenever we have two sides and the included angle, so two sides and the angle in between, or if we have all three sides. Let's have a look at some examples. So first of all, you are given the cosine rule in your formula booklet in this form. So the way that we label the triangle is identical to how we did so with the sine rule. You've got little a, you've got big A, big B, big C for your angles, and then the opposite sides are the lowercase letters. So if we want to work out the missing sides of these triangles, the first thing I would do is label them. So if I look at the triangle on the left, I want to find x. Now, the side that we want to find is always little a. So I'm going to label that little a, which means that the 45 has got to be big A. And then little b could be the 15, and then little c could be the 9. And then we can substitute our values in. So first of all, let me state the cosine rule. So a squared equals b squared plus c squared. Take away 2bc cos a. It might be easy for you to think about this as b and c always being the sides which have a as the included angle, and then little a as opposite to the angle that we have. But in any case, now we can substitute the numbers in. So a is x, so we have x squared equals b squared, which is 15 squared, plus 9 squared, take away 2 times 15 times 9 times cosine 45. So we can substitute this into our calculator. So let's have a look at this now. So we can put this in 15 squared plus 9 squared, take away 2 times 15 times 9 times cos 45, close bracket. This gives you 115.08, so 115.08 and so on. Then to get x in its own, we would need to square root both sides because the opposite of square is square root. So if I do that, and now I can just use the calculator memory, that's the easiest thing to do. So I can just put square root ands, and I get my answer 10.73 centimeters to 2 decimal places. In the second question, I can do a similar thing. So this time I want to find, in the second question, first thing I'm going to do is work out the missing angle. Because again, I need two sides in the included angle in order to use the cosine rule. So this angle here, I can calculate by adding 60 and 45, which is 105, and then taking away from 180, which will give me 75. So if we do that, we have 75 degrees here. I now have two sides in the included angle, so I can use the cosine rule. So I'm going to call the side that I want A. That makes big A 75, B 7, big B 45, C 12, big C 60. So what we can do now is use the cosine rule. So let me state the cosine rule again. Let me just get some space here. So a squared equals b squared plus c squared, take away 2bc cos a. So x squared equals 7 squared plus 12 squared, take away 2 times 7 times 12 times cosine of 75. And I can substitute that into my calculator. So we have 7 squared plus 12 squared, take away 2 times 7 times 12 times cos 75. So I get 149.52. And to get x in its own, I can square root both sides. And I'm going to use my calculator memory. So I press square root and I get 12.23 centimeters to 2 decimal places. Here are some questions for you to try. Please pause the video now and have a go, and when you're ready for the answers, press play. Here are the answers. Very often we want to use the cosine rule to find missing angles. So in these questions I want to find angles alpha and beta. So what I'm going to do again notice I've got all three sides, so this is when we'd use the cosine rule, not the sine rule. So firstly, the angle that I want to find is always big A, so I'm going to label the angle that I want, which is alpha in the first one, as big A, which means that the 5.4 centimeters is little a, big B, little b, big C, little c. So we need to use the cosine rule again. Now I'm going to write the cosine rule and then I'm going to rearrange it. So the cosine rule is a squared equals b squared plus c squared. Take away 2bc cos a. But we don't use it in this form if we want to find the angle. What I need to do, I want to get cos a on its own. So the first thing I'm going to do is add 2bc cos a to both sides. So I get 2bc cos a plus a squared equals b squared plus c squared. I'm now going to subtract a squared from both sides. So I have 2bc cos a equals b squared plus c squared. Take away a squared. And finally, I'm going to divide both sides by 2bc. So I get cos a equals b squared plus c squared, take away a squared over 2bc. Now, you can either rearrange it every time to get that, or you can just remember it. So if I write this up here, so cos a equals b squared plus c squared, take away a squared over 2bc. So for the first one, let's use this. I have cos of a, so cos of alpha, equals b squared, which is 6.8 squared, plus c squared, 7.5 squared, take away a squared, 5.4 squared, over 2bc, so 2 times 6.8 times 7.5. So let's put this into our calculator so we can use the fraction button. So I have 6.8 squared plus 7.5 squared, take away 5.4 squared, over 2 times 6.8 times 7.5. So I get this, 0.7189, and so on. And to get alpha on its own, I need to take cos minus 1 of both sides. So alpha is cos minus 1, or inverse cos, 0.7189, and so on. Easiest thing to do is to use our calculator memory. So I'm going to press shift cos to get cos minus 1, and I get 44.03 degrees. Similarly, in the second question, this time beta is the angle that I want, so I'm going to label that A, and then it doesn't matter if I put B on the right or the left angle, doesn't matter. Same with C. So this time cosine of A, which is beta in this case, cos beta equals 5.8 squared plus 12.5 squared, take away 10 squared, all over 2 times 5.8 times 12.5, and we should end up with beta. Let me just put this in. So we should have 5.8 squared plus 12.5 squared, take away 10 squared, over 2 times 5.8 times 12.5. That's cos beta, and to get beta I need to do inverse cos of that, which gives me 51.69 degrees. Here's some questions for you to try. I'd like you to work out angles theta and lambda this time. So the triangles are the same, but you need to work out angles theta and lambda. So please pause the video now and have a go, and when you're ready for the answers, press play. Here are the answers.